Problem number 5, longest palindromic substring from LeetCode. Let's jump to the question. Give me a string S, return the longest palindromic substring S. So let's see what palindromic is. So a word, a phrase, or sequence that reads the same backward and forward, something like madam. So if you read it from left to right or from right to left, it's going to be the same. So this is palindromic, and what we are going to look for here, we have a string. We are looking for a substring, the longest substring that's palindromic, something like BAB or ABA, right? And BAD is not palindromic, so that's not the case. And we can either return BAB or ABA. We are looking for just one valid answer, which is the longest palindromic substring. And for this case, for example, we are going to return BB. So let's see how we are going to solve this problem. So for palindromic cases, it's worth to mention that we have two different kind of palindromic. One is like odd. What I mean by that is like there is only one center character, and then the characters around it are like palindromic. So you see we have AA, we have MM. So madam here is a palindromic word. Or for example, here we don't have one single character, we have two characters as a center, and then we have BB. So we will consider this as an odd case, and this is an even case. So we should consider this when we are programming for getting the longest palindromic substring. For doing that, we are going to use two pointers. For the odd case, we are considering two pointers are pointing at the same index, right? Index I, let's say this is index I, and they are both pointing at index I. And for the even case, we are going to consider one pointer is pointing at index I and another pointer is pointing at index I plus 1. And then we iterate over the string until we get the answer. So how are we going to do that? We are going to say we are going to consider start and end index. These are the indexes for the final result that we are going to return, right? We are going to consider a start and end index, and we are going to start from index 0. We are going to start from the beginning, and this we are going to use a helper function to see if it is palindromic or not. So this is the main body of work, and here is where we are going to check if at that at that index that the pointers are pointing, that substring is palindromic or not. So this is just for checking for being palindromic or not. And here is the main body that we are going to consider both cases. This is for odd cases if pointers are pointing at the same index, and this is for even cases if we have two characters as a center of or substring, right? And what we're going to do, we're gonna expand around this character. For the first one, we're gonna expand around this and see if it is palindromic, and for the second case we are going to expand around this and see if it is palindromic, right? And we're gonna get the longest one, the max of it, and we check it with the final result that we are storing here. And if it is longer, we're gonna update this, and we keep iterating over the whole string until we get the longest one, and we're gonna return the result based on the start and end index that we are updating throughout the string iteration. So let's start. So at the beginning we start from index 0, as I mentioned. So for this case we are going to get the length 1 and 2, and for this case the pointers are both pointing at index 0 here, and for the second case the pointer is pointing at index 0 and the other one is pointing at index 1, and we are going to calculate the length using this function that we have here, and we get the max of these two. So let's see how we are going to do that. For this part we go deeper. So here As you see, we are going to calculate length 1 and we are going to calculate length 2, but you can see more details here for index 0. So for this one that the both pointers are pointing at index 0, we are going to check if the left index, we want to make sure these indexes are in range. If it is out of range, we can just like go to the next index. But if it is in range, then we will check for being palindromic or not. So for first two conditions are just making sure that's in the same range of the string that we have, and this condition is the one that is checking for palindromic, right? So it's saying like, okay, this is the left one and this is the right index that we have here. We are checking, okay, 0 is bigger or equal to 0 and 0 is smaller than the length of the string, so it is in range. And then we check if the index 0 and index 0 are equal, which is obviously they are equal, and if they are, we are going to check the left one is going to point at this and the right one is going to point at that. As you see here, the left one is out of range, so it's automatically, it's gonna be, the condition is not correct, so we cannot continue. So we are going to minus the right and left indexes that we had, which was 1 and -1, and return 1 as the length of the longest substring so far here, which you can see is just one character, so the length is 1. And for the second case, as I mentioned, we are not going to let's change the color. We are not going to have the pointers both at the same index. One pointer is going to point at index I, and the other one is going to point at index I plus 1, which is 0 and 1. So it is checking if it is in range. Okay, 0 is bigger or equal to 0 and 1 is smaller than 5, and then it's going to check if these two are equal, and if they are equal, so we might have even case, and if not, we can just the condition is not valid, and we go to the return, and 1 minus 0 minus 1 0, we're gonna return 0. And we got the length 1, which is 1 from here, and we got the length 2, which is 0 from here. We get the max. So far the longest palindromic that we have is just letter B. And then what is if we go here, so we're gonna check if the length that we got, which is letter B, is bigger than the start and end indices that we have here, which we by default from the beginning we set as 0, so we consider, so there is no palindromic substring. So 0 minus 0 is gonna be 0, so 1 is bigger than 0, so the one that we got from here, which is letter B as a substring, is bigger than the one that we had before. So we update the start and end, and start and end are pointing at, they're considering letter B as the longest substring so far. So as you see here, and now I is equal to 1, so we are at this point now. So for this one, both pointers are pointing at letter A at index 1. We're going to calculate the length 1, and which is like it's going to be 3, because it was checking here, so it was from here, it was checking these two, and it was palindromic, and then when it was doing this it wasn't, so it stopped doing that. So the length of the longest palindromic for the length 1 at this point, when the pointers are pointing at letter A, it's 3. And we're going to calculate for length 2 when one pointer, let me change the color. So when the pointer is pointing at this one and this one, and as you see here, it's going to be the second step, and it's going to be 0 because these are not palindromic, right? And we get the max, so it's gonna be 3. So far this is the longest palindromic. And then we check the length. If the length that we have, which is 3, is bigger than the 0 that we had before, we are going to update these two. So start is going to be from 0 and end is going to be from the tilde to index 2, and then I is going to be equal to, so I is here. We're going to check the odd cases, so it's going to check if this is palindromic, which is palindromic, and it's going to check these two, which is not palindromic. So the length 3 for this case is going to be the answer, as you can see here, and then it's going to check these two to see if first of all these two are palindromic, and if they are, then it's going to check the other characters beside it, and which is not, they're not palindromic, so it's going to be 3. It's same as before. This one length was 3 and this one length is 3 too, so it's the same, and but it's going to update the start from here to here, and then keeps doing that. It's going to iterate over 3 and keeps doing that until it reaches the end, right? So the time complexity for this case is a quadratic time complexity. The reason is we are going iterate over the string once, and then for every single one of these we are going to call a while loop here, so we have quadratic time complexity. And for space complexity, as we are not using any extra space, it's constant space complexity. Thank you.